Hello, in this video we're going to go over a problem on complex numbers. So the problem is asking us to prove that for complex numbers z1 through zn satisfying the sum of the absolute values squares equals 1, there are epsilon j's from the set plus minus 1 for which the sum of the epsilon j zj in absolute value is less than or equal to 1. So the first thing I'm going to do is I'm going to start with taking small cases. But one thing that I do notice is that I can multiply the inside by a negative sign without changing anything. So in other words, I can always assume that epsilon 1 is equal to 1. Now let's look at n equals 1. For n equals 1, the left hand side absolute value of zj is already 1, so we have the equality in fact. For n equals 2, we are going to simplify absolute value of z1 plus minus z2 squared, and that would give us absolute value of z1 squared plus absolute value of z2 squared plus or minus 2 real part of z1 z2 bar, and that can be done by just multiplying z1 plus minus z2 by its conjugate. So we notice that if the real part is positive, then we choose the negative sign. If the real part is negative, we choose the positive sign. Let's move on to n equals 3. For n equals 3, things get a bit more complicated because expanding that gives you a lot of different terms. However, if we could somehow use the case n equals 2 and we could write down the absolute value of z1 plus epsilon 2 z2 plus epsilon 3 z3 squared less than or equal to the first term plus the second term squared, then we could use the inductive hypothesis or n equals 2 and we would get the result. So how do we deal with that? We notice that the assumption that they gave us in the beginning, the assumption that absolute value of zj squareds add up to 1, is in fact sort of artificial because you can multiply both sides of the inequality by a scalar, by a positive scalar, and that would not change the inequality, but it would change the initial condition. In other words, we can rewrite the problem into sum of epsilon j zj's in absolute value squared is less than or equal to sum of absolute value of zj squared. In other words, we are going to prove something slightly stronger, although it's really the same problem. For complex numbers z1 through zn, there are epsilon j's from the set plus minus 1 for which absolute value of epsilon j zj squared is less than or equal to absolute value of zj's squared, sum of the absolute value of zj squared. If we prove this, then we are done with the problem as well, because in the problem they gave us that the sum of the absolute value of zj squares are 1. So if you replace that by 1, we get exactly what we wanted. We are going to proceed by induction. For n equals 1, epsilon 1 equals 1 works because the left hand side and the right hand side are in fact the same. For n equals 2, we let epsilon to be plus minus 1 and we expand this and we get absolute value of z1 squared plus absolute value of z2 squared plus 2 epsilon real part of z1 z2 bar. If real part is less than or equal to 0, we let epsilon 1, and if real part is positive, we let epsilon negative 1, and that settles the case n equals 2. Assume that we know the inequality holds for n. We are going to prove it for n plus 1. Using the basis step, we can find some epsilon n plus 1, the sum of the epsilon j zj from 1 to n and epsilon n plus 1 zn plus 1 is less than or equal to the sum of the epsilon j squared plus absolute value of zn plus 1 squared. Now we are going to use inductive hypothesis. The sum of the epsilon j zj from 1 to n squared is going to be less than or equal to the sum of the absolute value of zj squared from 1 to n, and we have a last term of absolute value of zn plus 1 squared. So if we add them up, we get the desired inequality. I hope you enjoyed this video. If you enjoyed this video, make sure you subscribe to the channel, and I'm going to place some similar videos on the screen, and I will see you in one of the other videos.